Do you want to create stunning isometric worlds for your game project or just as standalone pixel art? Well, that's a great idea, because isometric pixel art is not only pretty to look at, it also has some advantages when used in games, especially those in which the player should have a bird's eye view over a large scrollable map from a fixed camera angle. And where compared to a classical top-down perspective, an isometric perspective gives this extra sense of three-dimensionality. So if this is exactly what you want, here are some fundamental isometric pixel art concepts that will help you with creating something great. We start with some basic shapes and how to draw them from an isometric perspective. We can then refine those basic shapes to get a variety of more complex shapes. And finally, we can use all those shapes as building blocks to create large and detailed isometric pixel worlds. By the way, why is it actually called isometric? Well, the word comes from the Greek words iso, which means equal, and metriki, which means metric. And it basically means having equal measurement, because the three axes that correspond to length, width, and height are drawn at equal scales and angles. Theoretically, any two of the three main axes should have an angle of 120 degrees between them, or 30 degrees when you measure it over here. However, a 30-degree angle in pixel art would result in lots of jaggy lines, which don't look very good and is usually something to avoid in pixel art in general. Luckily, clean lines like this still come close enough to our desired angle. And this is why in isometric pixel art you usually see those staircase lines with steps of 2 pixels. Compared to a vanishing point perspective, parallel lines in isometric perspective stay parallel in your canvas too, and distances along the three main axes are undistorted and can therefore be measured accurately at any point in your image. What this means is that, for example, a distance measured over here stays the same when measured a bit further up in the image, which would not be the case in an image drawn from a vanishing point perspective. Because of this, an isometric perspective is often chosen in technical drawings and illustrations too. And of course in many tile-based video games. Especially for those, it is essential to have an isometric tile as your main fundamental building block. But also for standalone pixel art, this can help you with mapping out your pixel world. So let's see how we can create such a standard isometric tile. Actually, there are a few different ways to do that. First of all, you can draw it in different sizes, depending on the size of the objects you want to draw on top of your tiles, and also depending on the overall resolution of your image or game and how zoomed in or out you want to show your world. For now, let's go with an isometric tile that fits in a bounding box of 32 by 16 pixels. I guess one intuitive approach for many people would be to start with 2 pixels here at the center of the top edge of the bounding box, and then draw our staircase lines down to the left and right, and then further down to the center of the bottom edge like this. And this is not wrong per se, because you do end up with an isometric tile. And it also does tile, so placing them next to each other like this to fill your canvas is possible. However, if we look at the bounding boxes, you can easily see that the bounding boxes do not nicely align in this case. Is this a problem? Well, not at all if you're just creating some standalone isometric pixel art images, because you can freely place your tiles in Aseprite like this and the result will look just fine. For a tile-based game, however, this becomes a bit of a hassle. Ideally, you would want an isometric tile that tiles perfectly also with regards to its bounding box, because then the game code that takes care of drawing all the tiles on screen becomes much easier, as it only needs to move from one tile to the next by a fixed number of pixels, rather than having to jump around awkwardly like in the previous case. It is possible, of course, but it's just not as nice as it could be. Also, detecting which tile the player is hovering over with the mouse cursor, or detecting which tile an object in the game currently occupies, for example, becomes a much simpler computation when your bounding boxes of the tiles are aligned nicely. So how can we draw our standard tile instead? Well, if you do care about perfect tiling, then this tile is your friend. It uses 4 pixels at the top and a double row of pixels at the left and right side. As you can see, the tile fits perfectly into our bounding box, and it indeed tiles perfectly too. You do have to accept the rather big blocks between the tiles though, but whoever writes the tiling code for your game will probably be much happier with this solution. Now that we have our isometric tile to map out the world, it is time to fill it with objects, and for that we start with some basic shapes. The first fundamental building block is an isometric cube or box. With those you can make buildings, rooms, furniture and so on. We start with a basic isometric tile which becomes the top of the cube. Then we just go down with vertical lines at the edges and we finish the cube with the edges at the bottom. If you want to make a transparent cube, you can of course add the other edges as well. Notice how the center vertical line is not perfectly centered, because we have an even number of pixels to choose from. This is not a problem, but just be aware that in this case you need to decide if you use the left or right center pixel to draw the vertical edge. If you're creating something just for the art itself and you don't need to care too much about perfect tiling in a game engine, you can also just go with a tile with 3 pixels at the top and bottom rather than 4 pixels, because then you have a clear center for drawing the vertical edge of the cube. Now we can add some basic shading to our cube. As always, when shading something, decide beforehand where your light should be coming from, and then make the faces of the cube lighter when they are exposed to the light source directly, and darker if they are facing away from the light source. Another common technique in isometric pixel art is to highlight all convex edges and darken all concave edges. What? A convex edge is an edge that folds out, so to speak. And a concave edge is an edge that folds in. So if we highlight all the edges that fold out, we get this result, which looks pretty cool. Of course, this is just one way for shading the edges, and you can always experiment with other styles too. Now we can let our cube cast a shadow onto the ground. Again, keep it consistent with the direction of your light source. The light could come from any angle and therefore affects the cube differently, but if you want to keep it simple for now, you can go with a light source that casts a shadow from a 45-degree angle onto the cube, which results in a shadow that we can easily draw with horizontal lines, like this. Now that we have some nice cubes, we can move on to the next basic shape. Cylinders. Cylinders are more tricky to draw because of the circular shape that is viewed from a tilted angle. Those circular shapes can be either on the top or on the left or right side of the cylinder. Let's start with the top one first. An easy method to create this circular shape here is to first draw our isometric tile like before. Now we can draw the bounding box around our tile and connect the opposite corners like this. Next we can select the ellipse tool in Aseprite by pressing Shift and U. Point at a pixel on one of the diagonal lines, somewhere close to the middle between the corner of the bounding box and the edge of our tile. Start holding the mouse button to draw our ellipse and point at the opposite pixel in the bottom right corner in our diagonal line. Let go of the mouse button and now we have our circular shape that fits perfectly in our standard isometric tile. The rest of the cylinder is easy to create. We can simply copy-paste the circular shape, move it up or down vertically and connect the two shapes with vertical lines like this. If you don't want the cylinder to be transparent, remove the lines that should not be visible. So now let's create the other type of cylinder with a circular shape on the side. This one is not as easy and usually requires some try and error until it looks correct, but a good method to get the initial shape is as follows. We start with the side face of a cube into which we want to fit our circular shape. Now we can draw on a separate layer the same face but viewed from the front without the perspective distortion. On yet another layer we can use the ellipse tool to draw our circular shape viewed from the front, inside the square. And now we can shift this front-facing ellipse back into perspective by doing it in columns of 2 pixels wide. The first 2 pixel column stays where it is. The rest moves up by 1 pixel. And then we repeat this for the remaining 2 pixel columns. This gives us a rough indication of the circular shape in isometric perspective, which we can now fill in and refine until it looks good. Make sure that the curve flows smoothly and avoid creating doubles. Turning this circular shape into a cylinder then is straightforward. Just like for the previous cylinder, copy-paste the shape, move it in the direction of our 2 pixel staircase lines to the length that you want to have, and connect the shapes. To shade our cylinders, we can subdivide the sides into a few segments like this and then shade them according to the direction of our light source. Again, we can also highlight and darken the convex and concave edges just like we did for the cube. Adding a shadow on the ground also works in the same way as we did for the cube. Now that we have two basic shapes, we can create some variations to expand our little library of building blocks. Especially our cube can be modified in many useful ways. If we, for example, cut it in half diagonally like this, we get a ramp with a 45-degree slope, which we can of course also create from the other three viewing angles. We can also modify the slope angle too and create steeper or less steep ramps. If we want, we can also go one step further and create some staircases from those ramp blocks. We simply cut out some steps at the slope that we already created and we get a nice variation of stairs. Or we can create some nice corner pieces from our original cube. You can get really creative here and create whatever you like. Also, our cylinders might be useful in other variants. We can, for example, create smaller and thinner versions that look more like pipes, and combine such pipes to more complex structures too. Feel free to play around with combinations of all parts that you already made to come up with even more complex building blocks. And with all those building blocks in place, we can now start building bigger and more detailed isometric pixel worlds. The parts that we have created so far are very well suited for buildings and rooms, so let's create some. As another general tip, it is a good idea to work with separate layers whenever you create a new detail in your scene that could also work as a new reusable part, because then you can easily extract it once you're happy with it and add it to your collection. Because who knows, maybe this part looks great in a completely different context too. If you think of it as a brick system like Lego, for example, you can add more and more interesting parts to your library and your options for creating isometric pixel worlds become endless. And of course, you don't need to stick to city or architecture type worlds. You can also create nature environments with less blocky and more free-form parts. For example, a cozy isometric landscape with a river and some mountains and a few farmhouses, which I created in this video.